Friends, this is Dr. Kamesh Kumar here, Assistant Professor of Mathematics, Kisan PG College, Simphavli, Hapur. I'm here to present my teaching concept, differentiation. So first of all, we will know what are the utilization or what are the usefulness of the differentiation. Differentiation can be used to know the speed of any vehicle at any instant. It is also used to estimate the rate of change of decay of radioactive substance at any instant of time. And it is also used to find the acceleration of a car at an instant. Except these three uses, differentiation, or we can see the derivative in mathematics, has many utilization and many usefulness. In broad sense, we can say that physically differentiation is nothing but the rate of change. Now we will know the differentiation is the rate of change in case of first example, in case of first usefulness, first utility. The first utility is that differentiation can be used to know the speed of any vehicle at any instant. How it is possible? Yes, now it can be understood by this example, by this demonstration, by this illustration. Suppose we have a car and it is moving in this direction. At any instant, or we can say time t naught equals to 0, the car is here. So the distance we can fix here s is equal to 0. And after time t1 equals to 5 seconds, the car is here, the position of the car is here. In this time period, in this 5 seconds time period, the car covers the 120 suppose 120 meter distance. So if we are talking about the average speed, so what will we do? We will do that the total distance covered, that means 120, divided by the total time period. The total time period is 5 seconds, equals to 24 meter per second. So if we are unaware from the concept differentiation, then we can easily say that the speed of car is 24 meter per second. But the loose point in this explanation is that we are assuming that the car is moving with a uniform speed, but actually in real life situations it may not, it may be or may not, but we have assumed here that the car is moving with uniform speed. Therefore we are saying that the speed is 24 meter per second. That means at if we are talking about this point, then the speed is 24 meter per second, and if we are talking this point, it is again 24 meter per second. But in real life situation it is not. We can understand this thing in other way. Suppose in the first second distance covered 35 meter, in the second distance covered, the car covered 20 meter, in the third second it is also covering 20 meter, and in the fourth second suppose 35, and in the last, if we are adding all these values, in the last we can conclude that the car covers the 10 meter. So in the first second 35 meter, if we are talking about the speed of the first second, so we can see that 35 is the total distance covered, and within 1 second Therefore the speed is 35 meter per second. Similarly, in the second, the speed is 20 meter per second. Similarly, in the third second, 20 upon this distance is covered in 1 second. So again 20 meter per second. And in the fourth second, 35 upon 1, that means 35 meter per second. Similarly, in the last second, we can say that the car covers 10 meter within the last second. Therefore the speed is 10 meter per second. The speed which we have earlier assumed that 24 meter per second, now we are in the different conclusion, that in the first second is 35, in the second it is 20 meter per second, in the third 20 meter per second, in the fourth 35 meter per second, and in the last 10 meter per second. This explanation is completely different from the previous explanation, but it is again not explaining the actual situation of the measurement of the speed. Actual measurement of the speed will be given by the concept differentiation. How it is possible? Let us look the next slide. Yes, it is possible. How? It is possible as, suppose we are developing here the concept. Suppose at any instant time t, the distance covered is s of t. Time का function होगा definitely. So st is the distance covered in time t, and when we are talking about a very small interval, small increment delta t in t, we get the distance as t plus delta t. So the difference between the s t plus delta t minus st, it is the difference between the delta t second, the distance between the delta t second, and divided by t plus time, divided by the difference of the time, the difference of the times t plus delta t minus t. So t se t cancel. We can say here it is the delta s. Delta s means the distance covered in the delta t second upon delta t. It is very small. It is again very small. And what is differentiation? Differentiation is it is not the differentiation. It is again the average. The differentiation is a limit when we measure this ratio, and when we measure when delta t tends to 0. So when delta t tends to 0, that means it becomes infinitely small, tending to the actual point t, and at that time the distance covered upon the difference of time interval in this situation, this ratio is called the differentiation. And this differentiation is at time t. This differentiation is at time t, at that point. That means it is describing the speed. It is describing the speed at that point, because it is the instantaneous rate of change. It is the instantaneous rate of change. So hope the concept is clear now. How can we define the differentiation? So at any point t, the differentiation can be defined as of the distance function s here. However, the function may be anything, any function, any continuous function. So ds upon dt, it is the notation of differentiation, and it is defined as limit delta t tends to 0, and this limit is taken when of what quantity? The quantity is delta s upon delta t. where that means this tends to 0, this tends to 0, but that quantity approaching to a finite value, that quantity is approaching to a finite value. So this is the concept of differentiation, and it is the, we can say here this is the rate of change, we can say here this is rate of change, but when we are taking the limit delta t tends to 0, then we can say that it is the instantaneous rate of change. We can say instantaneous rate of change. Yes, have a look on this example. The concept of the differentiation which I have discussed here, it will be definitely clear by this example. The example is st is equal to t square, and here first of all we will calculate the s del t plus delta t, which is nothing but t plus delta t square minus t square. So it is nothing but t square plus delta t square plus twice t delta t. It is nothing but a plus b whole square. 10th क्लासेस का फॉर्मूला है ये, माइनस टी स्क्वायर से टी स्क्वायर कैंसिल आउट. So here we can say that delta t square plus twice t delta t. So it is the value of s t plus delta t minus st minus st. Here I can write minus st. So t plus delta t square minus t square, s plus st plus delta t minus st. So this quantity is delta t square plus twice delta t. It is nothing but it is delta s. So what will be the differentiation, or we can say the speed at time t, ds over dt equals to limit delta t tends to 0, delta s is delta t square plus twice t delta t upon delta t, and when we take the common limit delta t tends to 0, taking delta t as common, so remaining part is delta t plus twice t upon delta t, and here we can say, here we see that delta t cancel out and delta t tends to 0, so only delta t tends to 0, so this quantity becomes 0. So the answer is twice t. So the differentiation of t square function is twice t. Differentiation of t square function is twice t. That means we can say that at t is equal to 1. So at t is equal to 1, speed is twice t, 2, and at t is equal to 2, speed is 4, and similarly at t is equal to 3, speed is 6. So at any instant we can calculate the rate of change, and it is speed in case of where s is the function of where s is the distance function, then this rate of change is speed. Otherwise, if we have a continuous function in general, then we get the rate of change of the function with respect to the independent variable. So this is the concept of differentiation. That's all from my side. Thank you very much. I am also thankful to Professor Divyayu Joshi ma'am and Professor Ritesh sir to give me such an opportunity to express myself. Thank you very much ma'am, and thank you very much sir.